Welcome everyone to Snorkel Science Talks, a series where we interview AI thought leaders and discuss themes around making AI practical. And today we're joined by Abby C., who is a researcher and educator at Stanford, who's also spent some time at Google, Microsoft, and Facebook. So thanks so much for joining us today, Abby.
Hi, Braden. Thank you so much for having me.
So let's start off with some background. We always like to hear basically what everyone's path to ML was, how you ended up where you are today.
Well, I studied maths in my undergrad, and I didn't really get into computer science until kind of near the end of my undergrad. I did some internships at Microsoft Research in Cambridge, but those actually weren't even on machine learning. They were on other areas of computer science, a bit more theoretical. So yeah, it was kind of accidentally that I got into ML. I applied for some PhD programs in the US without having, honestly, a very strong idea of what kind of computer science I wanted to do. And then having got to Stanford, then it kind of seemed, it was like 2015 and the deep learning renaissance was just kind of a few years in. So it was a very exciting time. And it seemed to me like that was probably the most exciting place to get started in my CS research career. So I worked a little bit with the Stanford NLP group and also the Vision Lab. And I ended up choosing NLP just because it seemed like, I've always liked language, working with language and studying it. So that was an area of interest, but also just the Stanford NLP group is a really outstanding group of people as well.
Yeah, no, I can definitely agree with that. I long admired the NLP group and great work that you all did at Stanford. So a great place to cut your teeth on machine learning and then make a big contribution as you did. Great. So, I mean, actually, speaking of, one of the places where a lot of our listeners will have seen you before is that you co-instructed the NLP, with deep learning class at Stanford with Chris Manning and Richard Socher. And from that experience, I know that class has often a huge number of participants and often coming from a wide variety of backgrounds. So you probably, are exposed to quite a few different, we'll say, people's backgrounds in ML and have a nice view of often the way they're thinking about it. We'd love to hear, given the theme of our science talks, any common misconceptions that you often found yourself, facing among students or those you're instructing around, what does and doesn't actually make machine learning work in practice.
I think a lot of people, maybe the general public who mostly read about AI through the media or even possibly through fiction, like movies and so on, maybe one of the primary misconceptions is that they often think of AI as AGI, right? General intelligence, and something that is kind of even sentient or like a whole agent that has whole intelligence. And they are not aware that most practical AI these days is narrow or applied to specific tasks. So I think that's a primary misconception in the general public, but maybe in my teaching where we had people who had studied more machine learning or computer science in general, I think a lot of people maybe put a lot of emphasis on machine learning kind of training models and making bigger and better architectures, and that being the kind of primary route to success or achieving what you're trying to achieve. And I think there is sometimes a lack of awareness of how much everything else kind of affects the effectiveness of these machine learning systems as well. So, choosing the data, for example, is hugely important, but also the kind of last mile stuff, such as how exactly you deploy it and understanding what exactly is your deployment scenario and whether that's a good fit with how you trained it and the training data, etc. I think that kind of stuff, which is maybe a bit less glamorous than coming up with some cool new architecture, tends to be a bit overlooked.
Yeah, I think that's one of the interesting challenges of academia where you need to do controlled experiments. And so it's easy and in some ways good practice to kind of lock parts of the pipeline and only modify others, often with the locked part being the data set, because that is often so difficult to collect. And then you iterate on all the models, and it makes for good comparison tables, makes for good benchmarks and things, but but sort of as you said, in practice, there's a lot of other pieces there that that do affect things, from what happens after you've trained the model, as well as where your data came from, beforehand.
Yeah, definitely. I think sometimes there are people who work in many different fields that could possibly use machine learning. And then, they very reasonably have the question, like, will machine learning or AI or neural networks solve my problem? And unfortunately, the question can't be answered all that simply, because the answer is usually it depends, and execution matters hugely.
Yep. Oh, and then I guess, speaking of interesting data sets, I know you've done a lot of great work in dialogue, in particular, natural language generation, I guess more broadly, pointer generator networks at Google, at FAIR, kind of controlling chatbots, different axes of their expression, and then the Alexa Prize, which you recently led a team that did very well, if I recall. So that's an application where I'd say a lot of consumers do have some amount of direct experience with, just given the presence of a lot of digital assistants in our life. What are the challenges of ML or NLP in that area specifically, natural language generation, that maybe make it unique or different in some ways, in what you need to consider to really make it work?
Yeah, this has been the focus of most of my PhD work, is neural text generation for various different tasks. And one of the reasons I chose this area is because it seemed to be an area that needed a lot of work, not just in making more effective techniques, but in even just understanding what were the problems with the standard techniques, and how can we improve on them, and how can we kind of measure those problems, given that evaluation is a big problem as well. So I think maybe one way to think about why text generation is so difficult is because, unlike, let's say, classification, where you have some input that might be text, for example, and then you want to classify it into one of several labels, which is essentially one decision, text generation can be seen as maybe a whole sequence of decisions, where if you're generating some output text, that's actually a sequence of words that you're generating. So this kind of sequential decision making makes it like a lot more complicated, because not only do you have the model which kind of decides which text is likely, you also have to have the method by which you generate that sequence, which is called the decoding algorithm. And I think the fact that you have these two very major components that both have a very big effect on the generated text, I think that's one of the issues that makes natural language generation very tricky to achieve, but also to evaluate and make progress on. And then, speaking of that evaluation, that's also a very big problem in the text generation community, given that it's quite difficult to accurately evaluate whether the generated text is good or high quality, or fulfills the desiderata that we wanted. And typically we can only really evaluate through human judgments, that is, asking people to look at the text and judge whether it's high quality or not. But that's quite tough, because you have to pay people to do that. It's relatively slow and more expensive. You can't do it as often or as quickly. And this, again, forms quite a big obstacle in the development and comparison of generation systems. So I'd say that's probably another major reason why generation is quite a tricky area.
Yeah, that output space, for sure. Not outputting one of a discrete set of labels, but potentially having access to not just a monstrous vocabulary of individual words, but then the sequence, as you said, means that space, just almost unfathomably large in terms of potential things that can come out of a
Right.
generation system's mouth, as it were, and yeah, the evaluation coming with its various challenges. How about on the data side, when it comes to obviously with that loose and large of a potential output space, that's a lot of parameters to train. Often does do best, at least in terms of recent years, with neural models, which we know are pretty data hungry. What have you seen be either effective or less effective, or problematic when it comes to getting the training data sets for those types of tasks?
Well, with dialogue in particular, one of the big problems with training data is that most of the world's dialogue data is private, right? So especially if you're interested in one-on-one conversations, there is a huge amount of that data out there on private servers, given all the messaging apps that people use all the time, and that is rightfully private. So the academic community can't train models on those. So this forms a problem, because often when we're trying to train dialogue models, we need to use whatever data is freely and openly available on the internet. And that tends to be of a different kind. So for example, Reddit is often used as a source of a lot of dialogue style training data. But there's very big differences between Reddit conversations and a one-on-one conversation. So for example, on Reddit, you have actually kind of branching threads where someone makes a comment and then many different people might respond to that. And it's not one-to-one, it's kind of many different people. So that's very different to a lot of applications that we're interested in, which tend to be kind of one-to-one chatbot and one user. So a problem with that is that some of the big neural generative dialogue systems that have been trained, like Mina and Dialogue GPT, they do, in part at least, use Reddit training data. So this can be a problem because it means that it's trained on a style of conversation or a kind of tone of conversation, and often a topicality that doesn't necessarily match what you're trying to do. So of course, the main approach to NLP these days is that you take a large pre-trained model that was pre-trained on what is hopefully a kind of general and diverse pre-training set, and then you fine-tune on something that more closely represents what you're trying to achieve. But I think even then, if you're trying to operate in the academic community and use openly available data sets, it's actually quite hard to find this style of one-to-one conversations that you might want to do. So for example, in the Alexa Prize, which is this competition we took part in, we are trying to have one-to-one conversations between the chatbot and the user on typically kind of personal topics. It's like chit chat, getting to know you, talking about interests, etc. So for that, we fine-tuned on a data set which was released by Facebook AI research called empathetic dialogues. And it's actually a synthetic data set, meaning that it was produced by having crowd workers talk to each other in a style of role play, where the idea is they're meant to be telling each other about things that have happened in their lives and be empathetic, but they are actually role playing. It's not necessarily something real. So on the one hand, this is good because it's quite controlled and it's the kind of topic and the kind of tone that we want. But on the other hand, it's not necessarily the best because it is a bit kind of synthetic. It doesn't seem quite realistic. So that can be problematic as well. So yeah, overall, I'd say dialogue does have a very big problem with the availability of training data in the style that you want. And then if you go and create the style that you want, sometimes the syntheticness can be a problem. As for kind of NLG, natural language generation training data in general, here I think a lot of the strength has come from the very big GPT style models, which pre-train on just massive amounts of diverse text from the internet. So the strength there is that because it is so much text from so many different sources, then it does learn a very robust and kind of general knowledge and language modeling. But this does bring some other problems. So for example, safety problems in that you have this very big and possibly unknown training source that may include all kinds of stuff that you don't want in there in terms of toxicity, safety, biases. So that can be a kind of a problem as well.
Yeah, no, the space of potential problems are definitely large there. You need a lot of data. A lot of that data is private. When you do find data, it's not a perfect fit for your problem, as you mentioned, and then the downstream safety issues and tonal issues and all of that. So as you sort of alluded to, I think we see this common approach where people will pre-train on various things and then try and get increasingly refined. As you have smaller amounts of data that's a better and better fit for your task, you can kind of add those in later to sort of work on a good base understanding of language and then get increasingly fit to your task. But from that point, I mean, this is an area where I'd say we have quite a bit of interest at Snorkel, is sort of making targeted improvements, targeted corrections, right? A lot of that control over training data is very interesting. And I know you did some work at Facebook, I believe, around sort of that piece, right? Not just general architectures or general data set collection, but trying to have a little bit more control in terms of what your model at the end of the day learns or expresses itself along different axes. Would love to hear a little more of your thoughts on how exactly you're able to make some of those targeted corrections that address specific failure modes or error modes.
Yes, so the work I did at Facebook on controlling text generation was quite, as it were, rudimentary in that we were trying to apply different techniques to get the neural generative model to generate text with certain attributes that we wanted. And the reason why I say it was quite rudimentary is because the attributes we were trying to control were quite basic. So for example, at least like at the time, with the kinds of models we were using, with the kinds of decoding algorithms we were using, there was quite a widespread problem with models writing kind of generic bland output, or sometimes even repeating themselves. So those were some of the problems we were trying to solve. And maybe at a slightly higher level, we were trying to affect some conversational behaviors, like how often the model asked questions, and whether it kind of stayed on the same topic or changed the topic to something else on this turn. So what we were doing is we were looking at some pretty simple techniques to try to allow the practitioner to specify like whether we want the model to generate something that is a question or isn't a question on this turn. The idea being that if we have control over that, then maybe we can kind of like move these different sliders around to get something that behaves the way we want it to. So I think it was an interesting study, and that it kind of revealed like what was the relationship between some of those conversational behaviors and how much users enjoyed the conversation and what else they thought about it. But I think as a kind of overall method to fix these problems, it probably isn't the best and most principled way forward, because I think, it's not really feasible that we can kind of like manually move these slides around to get things right. And in the following years, I think these increasingly large GPT models have shown that scaling up in size and amount of training data and some other advancements that have been made have kind of fixed some of these problems with bland responses, for example. So that doesn't mean, though, that control is not still an interesting question. It absolutely is. So even with the best generative models we have now, which are able to generate quite long passages of text that seem quite convincing, and in fact, there are some studies to show that humans are not able to distinguish them from human written text in some cases. I think control is actually still just as important as ever, because, as you said, when there is such a large space of things that could be generated, then your scope for things going wrong is so much larger. And in fact, if you're able to generate even longer and more convincing text, then now we have to worry even more about things like fake news and how these things could be used. So yes, certainly, I think there's a great deal of interest in the scientific community right now about looking at how can we enact different kinds of restrictions on the output of these generative models. So maybe a concrete example that's probably more achievable soon, I think, would be kind of factual accuracy, sticking to what is grounded in some source document. So for example, in summarization or an abstractive question answering, you're writing new text, but it needs to be factually grounded in some source document. And one big problem with the neural models is that they are so good at kind of paraphrasing and using their own knowledge that they've learned from pre-training, is that sometimes they kind of hallucinate, as we say, meaning they write things that aren't founded by the source document, but which they've just kind of made up as being plausible in general. So this is a big problem, and probably is the main thing that stands in the way of neural generative models being used in these kind of applications. So yeah, this is an area of research, is looking at how can you kind of control them to make sure that everything they generate can be founded in something that was mentioned in the source document.
Awesome. And you already led into, I guess, the last topic I wanted to get your opinion on, which is, on your website you say you've got research interests in improving natural language generation and applying it in real world scenarios, and especially as you look at sort of what happens in a lab with fundamental research and sort of proof of concepts, like you describe some of your dialogue control work, versus trying to make this be at a point where it's acceptable to put in front of people and interact with more of the real world. What sorts of follow-on work do you see most necessary, or metrics or processes or other considerations need to be developed most before we're at the point where we feel increasingly comfortable with these generative models being ready to really interact on a large scale with humans?
Yeah, that's a really important question, and a big question too. So I think there's a lot of different parts to this. So one, I suppose, is you mentioned how people react to these models. And I think that in itself is something that's evolving. So for example, in our work with the Alexa Prize, one of the things we looked at was how people react to neurogenerative models when they're chatting with them. So in particular, what kinds of mistakes do the neurogenerative models make, and how does that interact with how people express whether they think the conversation is going well or not? And we found some interesting things about how different users had really quite varying expectations for the conversations. So I think given that these kinds of long conversation social bots are not yet a familiar part of life for the US-based users who were talking to them, those users hadn't really all calibrated their expectations the way, for example, now we're all very used to having virtual assistants like Siri and Alexa. We've kind of calibrated our expectations for what we think they can do right now. But people had really different expectations for what they thought our social bot should be able to do. And I think it'll be interesting to see over the coming decades whether people kind of converge to the same expectations and desires of like what they want these companions to be, right? So should they be companions, as I just said, or are they not really social companions? They're more just kind of like assistants. I think that's an interesting conversation that probably there won't necessarily be a consensus on, because some people kind of dislike how technology is, becoming a bigger and bigger part of our lives, whereas other people embrace it. So I think that's a big part of it, is that users themselves have a lot of different opinions about how they want these to be. But I think there's certain kind of indispensable advancements that need to be made just for these generative models to function as intended. So we spoke earlier about factual correctness. That seems pretty indispensable if you're going to try to have a knowledge-grounded conversation. There's also safety concerns. So one of the problems with our bot in the Alexa Prize is that we blocked it off from talking about anything which was in any way controversial, because we hadn't, adequately built its ability to talk about those things appropriately, so we just blocked it off. But that can be quite disappointing to users, because sometimes they actually want to talk about these things because they're very important to them as issues. And it can be disappointing for users if we set ourselves up as, hey, this is our chatbot, you can talk about anything, it's open domain, but then say, actually, no, we can't talk about that. So I think certainly in the future, you would want these chatbots to be able to talk about sensitive issues and divisive issues in a way that is appropriate, knowledge grounded, and yet doesn't exclude any users from the conversation, which is a really tall order. And we'd have to think carefully about how we want to do that as well.
Interesting. So it sounds like, there are some technical advancements to be made. There are also, we'll say, some societal expectations or things that need to be in line, or coordinated to, as you said, sort of converge in the middle, most likely in terms of where we end up at some sort of stable point in the future. Very interesting.
Yeah.
Well, thank you so much for joining us, Abby. And before we go, where can interested listeners find you on the internet? Where can they find what you're up to?
Well, you can find my Stanford webpage. I suppose I post some of the stuff I do there, and then I have a Twitter, but I'm not all that active on it because I'm trying to reduce how much I use social media. But yeah, I suppose those are the main places.
Awesome. And we can include those and links to some of the other work you've mentioned today, along with the video and article. So thank you again so much for joining us, and we'll be back soon with more science talks about how to make AI practical.
Great. Thank you, Braden.
Thanks. Bye.